Hi everyone, welcome to lecture 5. In this lecture, we will talk about inequalities and how to solve inequalities in one variable. But before we start how to solve inequalities, we have to look at what an inequality is and what the properties of an inequality are. Okay, so from our last lectures, we have seen a linear equation in one variable, and it's given in the form of ax plus b, where a and b are real numbers equals to 0. And linear inequality in one variable is just when we change this equality by an inequality, and that inequality could be less than or equal to, greater than or equal to. So these are what we call linear inequalities in one variable. As you can see, there is one variable in each of them, and that's x. And those two are coefficients, they are real numbers. And of course, there is an inequality involved in each of them, and that's why we call them inequalities. Okay. Now, the difference between linear equation in one variable and linear equation in one inequality in one variable, it's not only the sign that we have in here, the equality and the inequalities, but when we come to the solution of each of them, they are quite different. So let me give you an example to show you what I mean by this. For example, if we have let's say x greater than let me start with the equation. So if we have x equals to 1, for example, on the number line, if I draw a number line here, let's say 0, 1, 2, and so on. Just these are good enough. And on this side, we have the negative numbers. So x equals to 1 is just one number. Let me. It's one number which is here. Okay, so it's a point on the number line, right? This is the solution, or this number is the one that makes this statement true. Now, how about if I have x greater than 1? Which number from this number line makes it true? If I have 0, 1, 2, 3, and here we have the negative numbers. So let me see. Let me keep this. Okay, so here, which numbers from this number line makes this statement true? Well, when we say x greater than 1, it means all numbers which are greater than 1 will make this one true. For example, if I take 2, if I take 3, if I take 1.1, and so on. How about 1 itself? Well, no, because we don't have equality here. It's not greater or equal to, it's just greater. So 1 is not greater than 1. Therefore, this, I can use this, I will use this. All numbers to the right of, we use this arrow to show this goes to infinity. Okay, we put arrow here. And here, I put this parenthesis to show that the number 1 itself, which means this number 1, is not included in the solution set. Okay, but all the rest, all the green numbers, like all the numbers represented by this green arrow, they make this statement true. So this is the difference between the solution of an equation, a linear equation, and a linear inequality. Okay, for a linear inequality, the solution is not just a point; it's a group of numbers. Okay, or it's an interval. I would say an interval. That would be a better phrase. But this one is just a point. Okay. Now let's see some properties of inequalities. before we go to solving inequalities, let's see some of their properties. Do I have it here? Yeah, I don't have it here. All right. Now, number one. The first one is, first, let me write this. Suppose we have arbitrary numbers, A, B, and C, and let's say these are real numbers. They are real numbers. Now, the first property is if X is less than A, X is a variable now, this is a statement or this is an inequality. So if X is less than A, then we can write this one as A is greater than X. Here, as you can see, I used less than, but here I used X, greater than. So if I switch these two numbers, or X and A, I have to switch this one. I have to make this one look to the other side, which means it was less than, but now it becomes greater than. A simple example of this one is, suppose we have, well, I can choose two numbers. So we have 2 is smaller than 3 or less than 3. Well, this is the same way as 3 is greater than 2. Okay, this is what I mean by this one. And the next property is if A is smaller than B, if A is less than B, and if B is less than C, then if we have A less than B and B is less than C, then what can we say about the relationship between A and C? Well, A is smaller than C. And a simple example of this would be, well, you can pick any three numbers. Pick any three numbers, and that will give you, oops. Okay, so if 1 is less than 2 and 2 is less than 3, well, then 1 is less than 3. Okay, that's what we mean by this property. So this is true for any three numbers, any real numbers. And then property number 3, suppose A is smaller than B and C is smaller than D, another number D. And then if we add the first two, A plus C is smaller than the sum of the last two, or the larger numbers B and D. So if you add A and C, they will still be smaller than or less than the sum of B and D. And you can take a simple example again using numbers. You can even use negative numbers. It doesn't matter. I'm taking positive numbers because it's more obvious. We deal with these numbers more often. But let's say we have -1 less than 0 and -2 less than 1. Okay, both of them are true. -1 is smaller than 0, -3 is smaller than 1. Then if I add the first two, -1 plus -2 is still less than 0 plus 1. If we add these two, we get -3 less than 1. And this is true. Okay. Therefore, this property is true for any real numbers. As long as these are true, these two inequalities are true, then this is true. And property number 4, suppose A is less than P. Okay. Then A plus, add some number here. Well, let's call that number C, is smaller than, B 3. plus C. And also A minus B minus C. Okay. So for addition and subtraction, still the inequality holds. If you add or subtract the same number on both sides, the inequality will not be affected. It will still be the same. If it is smaller, if it is less than, it will still be less than. If it was greater than, it will still be greater than. Okay. And property number 5. Okay, now let's say C is positive. Suppose C is positive number and A is less than B. Then now if we multiply both sides by C, then still the inequality holds. A times C is less than B times C. Okay, and if you divide both sides by C, still the inequality holds. It doesn't change. Okay. Now is the trick, a bit like you need to understand this one. Okay. And I will try to make it as simple as possible. So let's see or suppose, I think that's better. C is a negative number or negative real number, okay? And A is less than B. This is still the same. Then A times C, B times C. Now I haven't put this inequality. And A divided by C, B divided by C. Now notice, this is less than B. This is a less than inequality. And we said C is negative. Okay, it's a negative number. A and B, we don't care about that, whether they are negative or positive. What we know about A and B are A is smaller than B. Okay. Now, if we multiply both sides by a negative number, C is a negative number, then what happens to this less than sign? It reverses. It becomes greater than. Okay. So A times C, because C is a negative number. Here we have the same case, but here in this case C is positive, so it doesn't affect it. Here C is positive, it doesn't affect it. But here C is negative and it reverses the sign. Okay. And similarly, here it reverses the sign. Okay. So always when you have inequality and if you multiply or divide both sides by a negative number, it becomes it reverses the sign. And why is this? Let's see an example. 2 and 1. Which one do you think is bigger? Which one is better? Well, with negative numbers, it's the opposite, right? As the absolute value, as the magnitude gets bigger and bigger, the number becomes smaller and smaller, right? As we go to the left, the numbers become smaller and smaller. Okay. So -2 and -1. -2 is smaller than -1. Okay. -2 is less than -1. Now let's multiply both sides by a positive number. Let's call that positive number, I don't know, 2. Let's multiply both by 2. 2 times +2, -1 times Let me use a different color. Now, what happens to the sign? Okay, before I put the sign, let's do the operation. -2 times 2 is what? Oops. No. Okay. Now here, notice 2 is positive. So this is example for property number 5, and then I will change this 2 to -2. Okay, and we will see what happens. So this is -4, and if 1 times 2 is -2, and still this inequality doesn't change. Okay. Now let's go to the other property. We have -2 less than -1. Then -2 times, now instead of multiplying this by -2, I will multiply it by, by +2. Now I will multiply it by -2. And then here we have -2. Okay. Now, again, before I put the sign here, I will do the operation. -2 times -2 is +4 now. Okay, I don't need to add this positive, but just to show you. Okay, it's just 4. If you multiply two negative numbers, it becomes positive. Again, here, if we multiply two negative numbers, it becomes positive. So this is +2. Now, you can easily see which one is bigger. Okay, we started with this one. We multiply both sides by negative number. It doesn't matter what that number is. Just as long as it's negative, then this sign reverses. Okay. So always when you solve, we will see with some examples. At a step where you multiply, when solving an inequality, I mean, if there is a step that you multiply both sides by a negative number, always reverse the sign. If it is less than, make it greater than. If it is greater than, make it less than. Or even if there is inequality, you make it the other, you reverse it, but still you keep the inequality. Okay. All right. Now let's go to solving some linear inequalities. Now, suppose we have this example. And this example, as you can see, it involves some fractions. And of course, it's an inequality. And it's always similar to that of the linear equation. When you solve such inequality, which involves fractions, you always try to get rid of the fractions because that makes life much more easier. So to get rid of these fractions, I have to find the LCD, the least common divisor of these three numbers. And that number is, we can see it's easily this one, the smallest number, because this one divides itself, this one divides itself, 6, sorry, this one divides 6 without remainder, and this number divides 4 without remainder. And another trick here, if you don't, if it is that difficult for you to figure out what the least number, the LCD is, usually it might not be the LCD, the least common denominator, but it works. So let's say you have 1/3, 1/5, and 1/4. Let's say you have something like this, and you don't know what the LCD is, and it's okay, maybe it's not difficult, but let's say it's difficult for me to figure out what the LCD for this one is. Okay, so what I would do is I would go and multiply these three of them, and that becomes 60. And I will take this as LCD. Okay, I will multiply both sides by this 60, and that makes my life easier. Okay, and then when I do this, you just simplify this one, and of course you have something on the other side. So this is just a trick that you can use. Okay. if you couldn't find the LCD and if it's kind of difficult, I mean, if you feel like it's difficult for you, you just multiply those three and you can multiply both sides by that product. All right. Now here, LCD is 12. Therefore, I will multiply both sides by 12. So we have 12 times y plus 3 over 4 minus 3y plus 1 over 6 greater than negative 1 over 12. Okay. And of course, I have to multiply this by 12 as well. We multiply both sides by the same number. Now, notice, this is a positive number. This is positive. Okay, so it doesn't affect this one. I keep the same inequality. If it was negative number, I could, because here I have negative, if you multiply this one by any chance, if you make this one negative by negative 12, then you have to reverse this number, okay? And here we simplify this, 12 by 4, it's 3, then we distribute that one. So I will just skip that step. So this will be 3y plus, sorry, okay. Let me write it then. I'm trying to save some time, but I don't want to confuse you at the same time. So let's distribute this one. Greater than, now here we can simplify because there is no, this is just negative 1. Now here we simplify it. So this is 3 and then 3 times y, we have 3y. 3 times 3, we distribute that one, 9. And then if we simplify this one, we have 2 remainder. So distribute that by this one, it will be negative 6y, and negative times plus, this is positive 1, right? Yeah. So this is negative 2 greater than negative 1. Now, just like what we were doing with linear equation in one variable, for this one, again, you have to add or you have to bring like terms together, okay? So here we have 3y and negative 6y. And we have to add this. These are the same, right? The same term. So if we add 3y and negative 6y, we get negative 3y. And then we have this one on the left side. So let me do that one first, and then we do it in the next step. So 9 minus 2 is plus 7 greater than negative 1. Now we have negative 3y plus 7. We subtract 7 from both sides. Okay, we subtract negative 7 from both sides. And this is just to isolate this variable, right? To isolate, we have to get rid of the 7, and to do that, we subtract 7 from both sides, and this makes it 0. So we have negative 3y greater than. So as you can see, I still have the same inequality sign because I haven't multiplied or divided by a negative number at any step here, okay? If I do that, this addition doesn't change it. Here we subtracted, but it doesn't change the inequality sign. And negative 1 times negative 1 minus 7 is negative 8. Now is the stage where we have to be careful now. So to get rid of this one, or to make this coefficient to 1, what do? We multiply both sides by negative 1 over 3, negative 1 over 3. And what is this now? Now, one thing that I need to notice that the first side is this number that I'm multiplying both sides by is again a negative number, right? So what does it do to the inequality? Well, it flips this one. It reverses this one, okay? So that's the first thing that I need to notice. Since this is negative, I have to flip this one. I shouldn't forget this, okay? And then the next is just we simplify this one, and then we have only y on the left side. And on the right side, we just do this operation, negative 8 times negative 1 over 3. The negative and negative becomes positive. So we have just 8 over 3. Okay. All right. So now what does this mean? How do I write this one? What is the solution set of this one? Now, at the same time, now we found the solution set, but I have to write this one in some form. What does this mean? So let's draw this a number line, because always the number line is the best way to visualize the solution set of an inequality or linear inequality. So 8 over 3 is approximately 2.666 or 2.67, right? So we have this. Okay, we have this number line. Now 8 over 3 is approximately 2.67. So let's say it's somewhere in here. Okay, here we have 8 over 3. Now the solution set of y, or this solution is the solution set of this inequality is y less than 8 over 3, which means any number which is smaller than this number makes this statement true. That's what this is saying. Now, what are those numbers? Let's shade it and represent them using by this shade. So starting from this, since this is less than, I go to the left. Okay. And here we have. And this arrow again, it goes to the infinity. In this, since it's going to the left, it means negative infinity in this case. Now, to write this one in interval notation, negative infinity because of this one, comma, and here we have 8 over 3 as a border line. So 8 over 3. Always with infinity or negative infinity, put this parenthesis. And with this one, if you look at this one, we don't have inequality, right? So 8 over 3 is not part of the solution. But the number next to 8 over 3 to the left is part of the solution. Now, we don't know what that number is because we have millions of numbers between 8 over 3 and the next. I mean, there are million numbers. So we don't know. I mean, we cannot tell exactly what that number is. Okay. So what we do is all the numbers less than 8.3. And all those numbers, to represent that one, we use this parenthesis. And this parenthesis means all numbers to the left of 8 over 3. But 8 over 3 is not included with the solution. So, okay, so I put here this one. If there was inequality, if there was equality here, I would change this by a square bracket. Okay, instead of this parentheses, I would use square bracket. Again, here I would use square bracket. That square bracket tells me 8 over 3 is part of the solution. 8 over 3 is included. Okay, so those are notations that we need to get accustomed with. Okay, now this notation we call it interval notation. This is what we call interval notation. Okay, and then set builder notation. I can write this same solution y such that, or I can write y such that y is less than 8 over 3. Okay, I think I will write this one. Okay, so y such that y is less than 8 over 3, and this is what we call set builder notation. So for the same solution of this inequality, linear inequality, I use this number line, okay, this number line, and this is the starting point. And then I use the interval notation, and I have this set builder notation. Now, unless if to specify, you have to use that. If I ask you to show or to write the solution in interval notation, then put it in interval notation. Otherwise, you can put in either of these two, not the number. Of course, you can use the number line or this line solution. It's good to show that one and to use it for yourself. But then the solution you have to write in one of this, okay? But if to specify it, then use the specified one. Therefore, the solution is just one of this one, solution to this inequality. Okay. Now, the next is, how about if our inequality or our linear inequality involves two inequalities joined by and or. Okay. In this case, if we have two or more inequalities joined by either of this one, or maybe both of them, we can use both of them at the same time if we have more than two inequalities, then this is what we call compound inequality. This compound inequality means it involves more than one inequality, or it has more than one inequality in it, okay? So to solve a compound inequality, the first thing that we need to do is we solve the individual inequalities first, okay? We do the inequality, we solve the inequality, and then we look what the two inequalities are joined by. If it is and, then we have something to follow, or the solution set. I will show you using this example. And again, if it is or, we use the union. So here we use the union, here we use the intersection, okay? Now, a simple example, let's take this. We have the same number, but I have different inequalities. I use different inequalities in both cases. So here I have x greater or equal to 2, and here I have x less than 5, and they are both connected by n. So if we use a number line for this one, what do we have? 0, 4, 5, this is 5, and okay, so here x greater than 2, 2 is here, okay, and then the second one is x is less than 5. So we start with 5 here, and we go to the right. Okay. Now, since this is and, this is an and, you take the intersection. And intersection means the interval where these two shades or these two lines intersect, or these two colors intersect, and that area is this part. Okay, this is where they intersect, the two of them. I put this line on top of the green one so that we can see it easily, but normally they intersect. One is over the other one. Okay, they overlap. So the intersection of these two is this interval, and that interval is between 2 and 5. So what we do here is the first interval, using interval notation, I write this one as negative, the first one is 2 to positive infinity. And now here we have square bracket. And the second one is negative infinity, this color. As you can see, it goes to the left. So I use negative infinity. I put in negative infinity here to 5. Now here, we don't have the square bracket because as you can see, this inequality doesn't have the equality sign. Therefore, these are the two lines, the two different colors, okay? One represents this interval, the other represents this interval. And since we have this and, we use the intersection sign symbol. And that one is this one. So the intersection means the intersection, or this symbol means the intersection of this interval and this interval. And that area is this one. So this intersection is the same with 2 and 5, from 2 to 5. That's the intersection of these two numbers, two lines. So the best way to see here this kind of intersection is to use this line, okay? Otherwise, from here, well, if you are comfortable with this, it's okay. You can, of course, figure out what the intersection is. But if you draw both intervals, like if you put them in this number line, then clearly you can see where they overlap. And that's where your solution is, okay? Now, for this one, 0, 2, 3, 4, 5. And here we have x less or equal to 2. Or let's put it the same way. Let's keep it the same way so that you can see the difference. I will use the same inequality, just like the first one. Okay. Now, so for OR, it's not the overlap now. What we do is just all of it, like all the shaded ones, shaded parts. So here we have, this is greater than 2, so we have, okay, now it is this. And then we have, starting from 5, we have this one. Now, what are those two intervals? Well, they are the same. We have those intervals here. But now, what is the result now? So I will write here, I will write this one, 2 to positive infinity, union. This is now the union sign, symbol, okay? And then negative infinity to positive 5. So this is union, or this is the or sign, okay? And that's one the end. So this means just add the two shaded parts, put them all together. And as you can see, if we include both of them, or if we add both of them, this color shares the number line all the way from 2 to the positive infinity, and the green color shares from 5 all the way to negative infinity. So is there any left, unshaded part left on this number line? No, all of them are shaded either by the green or by the other one, right? So the solution set to this one or this is equal to negative infinity all the way from here to all the way to the right, which is positive infinity. Sorry, that's positive. This is positive, okay? And so this, the union of these two intervals is just the whole number line itself, okay? We don't care about the intersection now. Just add all the shaded parts, and that's the whole number line, okay? Now let's see how to solve this, such kind of compound inequalities. And we will follow the steps. So consider this. We have negative 4 over 5m over, less than 8, and 0.85 less or equal to 0.34 m. And I will circle this one so that we can see it at the end. It's always a good idea to just write it down at every step, but if not, remember it at the end. So for this one, now I will get rid of this 5. And to do that, I will multiply both sides by 5. Okay, I'll multiply this by 5. And then this, they cancel out. We have negative 4m less than 8 times 5 is 40. and I have this end. And how about this one? Okay, let's finish this one, just the first part. Now, here we divide both sides again by, sorry, 1 over negative 1 over 4, and multiply by negative 1 over 4. And what do we get? This is m, and this is negative 10, 40 times negative 1 over 4. How about this one? The inequality now, we reverse it. Okay, it looks to, it faces to the other, to the left side. Okay, therefore this is m greater than negative 10. And what is the interval notation of this one? How do we write this notation in terms of interval notation? In terms of set notation, this is m such that m is greater than, just put this interval in it, or this solution set. So it becomes m such that m greater than negative 10. This means all numbers, all real numbers which are greater than negative 10. That's what it means. Okay. And the interval notation of this one is m greater than negative 10. So it means from negative 10 on the left side all the way to positive infinity. So I will put negative 10 here, parentheses, because I don't have inequality, and then we have the infinity. And here, and again, for this one, I have to get rid of this decimal. And to get rid of the decimal, let me wait a bit here. I will multiply both sides by 100. Okay, so that we get rid of this decimal. And 100 times this one, we get 85. Now remember, this is positive, so this is not affected, and this is 34m. And again, we multiply this one by 1 over 34, 1 over 34, and what do we get? This is 85 over 34, that's equal to m, which means this is the same with m is greater than 85 over 34. And 85 over 34 must be, what is it? 85 over 34 is 2.5. Okay. This is 2.5. Okay. So what does it mean? This means m such that m is m is greater than or equal to 2.5, or we can write this one as 2.5 to positive infinity. No, this is just for set. This has to be just this one. Okay. Now, don't forget, we have this n now. We have this n. So how do we find the solution set of this one? So the solution set, these are the individual solution sets. It's not the solution set to the whole compound inequality. Okay. Now what we need to do is, we have the inequality, the individual ones, and I have to put this in a number line so that I can see it clearly. So in a number line, start with 0, negative 1, sorry, positive 1, 2, 3, 4. These are good enough on the positive side. 2, 3, 4, 5, 6, 7, 8. So we have -10 here. Now let's use color. So the first one is from -10 to +infinity. So I would start from here. I created another line. Anyway, that's okay. And the other one is you start from 2.5. Say 2.5 is halfway here. And again, that one goes to the right again because it's to +infinity. Okay, so we have these two lines. And I have to put the parentheses, the bracket. This is square bracket because 2.5 is included, but this one is curly bracket, sorry, this parenthesis. Now, since this is and means it's intersection, and intersection means overlapping. So what is -10 to +infinity? Intersection 2.5, this is square bracket, to +infinity. Now what is the intersection of this one? Just look at the colors now. The green one starts from -10, it goes all the way to +infinity, and the other one starts at 2.5, and it goes all the way to +infinity. So we don't see the numbers in here, but they both goes to +infinity. So they overlap, that means, okay? So starting from this, they go together. Therefore, this is the same way as 2.5 to +infinity, just this interval, okay? Therefore, the solution to this inequality or to this compound inequality is I will just write it in interval notation, is 2.5 to +infinity, okay? You can convert this one to set notation if you want or if you are asked to. And you can try any number now. Just pick any number. Any number greater than 2.5, let's say 10. If you pick 10, try it here. -4/10, this is -8 on the left side. And here we have 80, and -80 is less than 80. And on this side, we have 0.85 less than 0.34 times 10 is 3.4. So this number is less than that one. But if you try a number somewhere from this area, from this green area, let's say 0, try 0 here. That's easier. So -4 times over 5 times 0 is 0 on the left side. 0 is less than 8. So it makes this one true. How about this one? 0.85 is less or equal to 0.34 times 0. On the right side, we have 0 because we are multiplying by 0. So we are saying this is 0, less than 0, which is false. So this green area here makes the first inequality true, but doesn't make the second inequality true. And what we are trying to find out here is, or trying to find as a solution is, the interval that makes both inequality true at the same time, okay? And that is only this part, from 2.5 to all the way to +infinity. Okay. And this is again another example. One has to be or. The first one is and. So this has to be or. Yeah. Let's change it to or. Okay. Now, let's solve this one by one again, the same steps. So I will add 6 on both sides. So from the for the first one, it's n greater than 7 or, and how about this one? We have to multiply both sides by 4 to get rid of this fraction. and we get 3n greater or equal to 24, and then multiply both sides by 1/3 to get rid of this 3, and we have n greater or equal to 8. And notice we don't change this one. Still, we have the same inequality because we are multiplying both sides by positive number in both steps. Therefore, we have the solution for the two separate inequalities or individual inequalities. And now I need to draw the number line. I have 0, 1, 2, 3, 4, 8. We have 8 here. We have 7 here. So let's draw them. Let's start with the first one. N is greater than 7. Here we have 7. So greater means go to the right. So we are going to the right, put arrow here. And then we have 8. N is greater than 8. Here is the 8. Start from 8 and go to the right again because it's greater. And I will go here. And what does this mean? And let's put here, this is not included. So this is just parenthesis. And the second one is square bracket. Okay, because 8 is included. Now the green one is 7 to infinity. Now since this is OR, I use the union. And the second interval is 8 to infinity. Now for OR, or for this union, we don't look at the intersection. The intersection is this area, right? This is the intersection. But since this is OR, it means sum of the two. Or look at all the shaded part, whether it's green or ignore the colors. That means now. In this case, we ignore the color. Just look all the shaded parts by whether it could be by the green or by the other one. So the shaded part is starting from 7 all the way to positive infinity. Therefore, that's what this is equals to. Okay, therefore, this is 7 to infinity. We're just trying to figure out which part of the number line are shaded, and we add those two. We put them together. Therefore, that's the solution set. So I put this one in interval notation, and that becomes the right solution. Solution set is n such that n is greater than 7, or in interval notation. Interval notation is just 7 to positive infinity. So that's our solution. Okay, and then we have this type of inequality. So here the inequality is not separate. We have both inequalities in one expression, okay, in one sentence or in one statement. And how do we deal with this kind of thing? So here we do the operations in all the three separate parts. Now let's try to solve this one. So for example, here we have this, and well, the first thing that I need to do is I wanted to get rid of this 9, right? So if we didn't have this last inequality and the 0, we would subtract 9 from both sides so that we get rid of this number 9, right? And we do the same thing now. So I will, we have -6, -3x plus 9 less than 0. Now here I subtract 9, subtract 9, subtract 9 on 3 of them. And then what do I have? Well, we just perform the operation, and this is -15. This is equal to -3x. This is 0, less than -9. And then we multiply both sides by -1/3, -1/3, -1/3. Now again, remember this is negative number. And what do we say if it is negative number? If we multiply both sides by a negative number? Well, we reverse all the inequalities now. So here we have 5. This becomes positive, and this becomes greater or equal to. And this is just x. And here I have, what do we have here? Okay. It will be 3. So this will be just 3. Okay. Therefore, x is between 3 and +5, or x is, I can rewrite this one. We can rewrite this one as 3 less than x less or equal to 5. Okay, this makes sense more because here starting with the number with the bigger number, this is more better way of writing it. Now, what does this mean? So x is between 3 and 5. Therefore, I can write this one as 3 and 5. Okay, this is what it means. Or on the number line, you can just, you have 3 and 5. So this is what it means. This is the shaded part. This is the solution set. Now, since this is about inequalities, and of course, inequalities can have or can involve absolute values, we will see how to solve inequalities which involve absolute values. Now, first, we have to remind ourselves what the absolute values or the properties of absolute values are. So, for example, if we have, last time I kind of explained this one a bit, if you have watched that video. So if we have absolute value of u less than k, always try to treat this absolute value as the distance of k, or the distance, okay? Because distance is always positive. That's what we agree on. So the absolute value of u is less than k. Well, which number satisfy this one now? We have to ask ourselves. If I have this, let's say we have this 0, and let's say this is k. And this is the positive k, and on the left side, you have negative k. So these two distances are the same in terms of, if we ignore the negative as a distance, these two are the same. They are equal. They are equal from 0, right? Therefore, here we are saying absolute value of u here is a variable, any number. It could be any number. And we are saying absolute value of u, or the distance of u from 0, is less than k. K is this one. So which numbers satisfy this condition? For example, if I pick a number from here, do you think it satisfies this condition? Well, definitely, because the distance of this number from 0 is less than the distance of k from 0. How about if I pick a number from here? Is the distance of this number from 0 less than the distance of k from 0? Distance of k is the same with the distance of negative k. Yes, this is smaller. Therefore, all numbers in this area, or in this interval, satisfy this condition. Okay. Therefore, this is equivalent with saying negative k less than u. U represents all the numbers in this interval. It's a variable. So negative k less than u less than k. So therefore, this is the same with this one. How about if I say u is greater than, absolute value of u is greater than k? Again, let's see. Let's say we have k here, this is 0, and we have negative k here. So we say absolute value of k is greater, absolute value of u is greater than k, and k is a variable. So which number satisfy this condition, or this statement? If you pick a number from here, is the distance of this number from 0 greater than the distance of k from 0? No. As you can see, this is short. This is longer, right? Therefore, any number in this interval doesn't make this one true. But if you pick a number outside this range, outside of this negative k to k interval, then that makes this one true. Okay? Either it could be on the negative side here or here on this interval. Okay? Therefore, this means either u is greater than k, which means this part all the way to positive infinity, or this is u greater than k, or u is less than negative k, and that part is all the way to negative infinity from negative k. If you pick any number from these two regions or these two intervals, they satisfy this condition, which means their distance, pick any number here, their distance from 0 is always greater than the distance of k from 0. Okay, that's the interpretation of this one. So I feel like it will help you if you interpret this one as a distance of a number from 0. The absolute value of u is the distance of that u from 0. Now let's see. Suppose you have now this inequality to solve, and remember we had this kind of example when we solve linear equations. We deal with this kind of stuff, but now the difference is it's inequality now, not equality. We have this inequality, but more or less is similar. Okay. All right. So the first thing that we need to do is we always want to isolate this condition, this inequality, the absolute value. Sorry, we have to isolate the absolute value, and to do that, we subtract 6 from both sides, and well, we have 9 on this side less than negative 2d minus 3 absolute value. Okay, when I will rewrite this one, as I will put this one on the left side. It doesn't make any difference, but just it's easier to see it. I will put this one on the left side. So this becomes, as you can see, it faces toward the absolute value. Therefore, yeah, it has to face to the absolute, toward the absolute value. So 9 is less than this one means this one is less than, greater than 9. And that's what we have here. So these two are the same. Okay. Now, this expression, treat this one as u. Treat this inside absolute value as u. Is this the same with the first one or the second one? Well, it's, as you can see, since this is greater, it's the same with this second one. And if we have this second one, this is what they mean, right? This means this one. So let's write this negative 2d, absolute value of negative 2d minus 3 greater than 9 as in terms of this. We will break it down. Therefore, this means negative 2d minus 3 is less than negative 9. I put negative here. Or, we have or, not and. Negative 2d minus 3 is greater than 9 as it is. Okay? And we just solved this one because it's the same now. We get rid of the absolute value and we solve this one. So here we have to add 3 on both sides. So we have negative 2d less than negative 6 and multiply both sides by negative 1 over 2, negative 1 over 2, and we have d greater than, and why is this? Because we multiplied both sides by a negative number. So I reverse this one, and this is positive 3. So one is this solution, the one solution is this one, and then I have or And the other one is we solve this one just like what we have been doing for all the examples. So this is negative 2d. We add 3 on both sides, so it becomes greater than 12. And divide, now we multiply both sides by negative 1/2. And what do we have? So this is d less than, because we are multiplying both sides by a negative number, and this is negative 6. Okay, so in interval notation, how do we write this one? This is 3 and above, right? So we start with 3 and we go all the way to negative infinity. And this or, we replace it with union, because or means union. And here we have negative infinity less than 6. Sorry, we don't put less here. This is comma. Okay, negative infinity, comma, negative 6. And if I put this one on the number line, let's see what that looks like. So this is actually, this is the solution set as it is, but I just wanted to show you. I will remove this one first. I'll show you on the number line first. 0, 1, 3, and 1, 2, 3, 4, 5, negative 6. Okay. So this is what we have. So the first inequality is from 3 and above. So we have this. And the second inequality is d less than negative 6. Negative 6 is this one. So less than means to the left. Let me use different color. Oops. Okay. And we have from negative 6 all the way to the left. And this is just parenthesis. Okay. Now, since this is OR, and as you remember, OR is just addition. You just add the two intervals, which means just look at, ignoring the color, which part of this number line is shaded. And that shaded part is the first part. The first shaded part is negative infinity to negative 6. Okay, this part, union, and the second part is 3 positive infinity. So this is the solution. And this is interval notation, of course. This is the interval notation. And the set builder notation, as a set, we write this one as d side that d, always use the same variable. D side that d is less than negative 6, or d is greater than 3. Okay, what you need to add here is this term, this part, and the curly brackets. The curly brackets are indication of a set, or those are what we use to represent a set. Okay, so this is all about inequalities, and I guess this is all about chapter 1. So next week we will start, or in the next lecture we will start chapter 2. Okay, so that's it. See you in the next lecture.